Dear students, in this class, we are going to learn about the prime factorization rule for number ending in zeros. Okay, let us do this with the help of an example. Let us take a number 4 is to n. Let's take a number 4 is to n. Now, let us check for any value of n whether the number 4 is to n ends with 0. Okay, let us take a number in place of n, let us substitute 4 is to 1. So, 4 is to 1 is 4. Okay, next we'll take in place of n, we'll substitute 2. So 4 is to 2 is 16. Next in place of n, let us substitute 3. 4 is to 3 is 64. Next in place of n, let us substitute 4. 4 is to 4 is 256. Now for any value of n in the number 4 is to n, you can see the number here it is ending with 4 when you substitute n is 1. Here the number is ending with 6 when you substitute n is 2. Here the number is ending with 4 when you substitute n is 3. Here the number ends with 6 when the number, so when you substitute n is 4. So this pattern will continue and will conclude that, and from this the conclusion is that the number 4 is to n for any value of n is not ending with zeros. Let us take one more example. Let us take the number 6 raised to n. Okay. Now for a value of n equals to 1, 6 raised to 1, the number is 6. The value of n, the number 6 raised to 2, the number is 36. The value of n 6 raised to 3, the number is 216. And the value of n 6 raised to 4, the number is 1296. Here for any value of n, the number 6 raised to n is ending with 6. So from this pattern also we can see that for any value of n, the number is not ending with 0. Let us take one more example. Let us take one more example, 20. Okay. Now let us substitute here. In place of n, substitute 1. So 20 raised to 1 is 20. Next, in place of n, substitute 2. 20 raised to 2 is how much it is? 20 raised to 1 is 20. 20 raised to 2 is 400. In place of n, let us substitute 3. 20 raised to 3 is 8000. Now here you can see for any value of n, the number is ending with 0. When you substitute n is 1, it is ending with 0. When you substitute n is 2, it is ending with 0. When you substitute n is 3, it is ending with 0. Okay. Now this is why it is so. Let us check it. Now when you do the prime factorization of 4, you can see the prime factors of 4 is 2 times 2. The prime factors of 4 is 2 times 2. Now when you do the prime factorization of 6, the factors are 2 times 3. The factors are 2 times 3. When you do the factorization of 20, the factors you'll get is 2 times 2 times 5. Okay, here is the clue. Here is the clue for you. Now you can see the factors of 4 you have only 2. In the factors of 6 you have 2 and 3. But when you see the factors of 20, you have 2, 2 and 5. This is the answer, 2 and 5. So when you multiply 2 and 5, the product is 10. And when you multiply 10 with any number, it ensures that the number is always ending with 0. So for any number to end with 0, its prime factor should include 2 and 5 in it. For any number to end with 0, its prime factor should include 2 and 5 in it, because 2 and 5, when you multiply, the product is 10, and you multiply 10 with any number, it ensures that the number is ending with 0.